Test. And welcome back to our chapter 18. Here we are in the third section talking about the application of lenses. So this is the last lesson in this chapter before moving on to chapter 19, talking about interference and diffraction. So here we are. So the chapter started talking about or describing the eye as a lens. Okay, so the eye is considered as the one of the most powerful lenses in nature. Okay, and it's remarkable, okay, optical device. Okay, so when the light passes through the lens, so as you see here, the light path passes through the lens of the eye, the light path converge to meet here, somewhere here on the retina before moving on by the nerves, using the nerves to the brain to give a meaning to the light or to form the image. So the image will be formed here and then transferred as information through electrical pulses to the brain. Okay, so let's read together here. The light then passes through the lens and focuses on to the retina, which is somewhere here, that is at the back of the eye. And then after that, using the nerves, as you see here, okay, the optic nerves to the brain. So it's transmitted to the brain after, and this, all of that happened just in milliseconds. So as you see here as well, we have the light rays coming from the sun hitting any object. These lights will be reflected again to meet our eyes. So that's how we see objects. Usually, before that theory, previous years, they thought that the light rays coming from the eyes to the object, which was a big mistake, which was wrong. And now we are describing that light come from the source, which is the sun in this case, hitting the object, and then it reach our eyes to give then a meaning to that object. All right, so using the eyes, but eyes, it's not a perfect system. It has some defaults or some mistakes. So usually in a perfect scenario, the light rays have to pass through the lens of the eye and meet at the retina. But sometimes we have this problem that's called nearsightedness, where the light rays not converge and meet at the retina, they meet somewhere before. They meet somewhere before the retina. So that's what we mean by nearsightedness. So of course in this case we need a lens, we need a type of lens, which is in this case a concave lens, okay, just to make the rays meet at somewhere away or here on the retina. So here again, to solve such problem, we need a concave lens. We need a concave lens just to push the rays to meet somewhere after the point that they already meet on. All right, so that's for the nearsightedness. We have another problem as well called farsightedness. It's similar problem but in opposite function. So in that case, the light hit the lens of the eye and meet somewhere after the retina. So I need a lens, which is in this case a convex lens, just to put or to push it forward, to push the rays forward to meet on the retina. So all these problems coming that the rays does not meet at the retina point. So that's why sometimes you use a concave, sometimes you use a convex lens just to make the rays meet at this key point, which is the retina. So reading together, so in this case, the focal length of the eye is too long. So this is in case of farsightedness. Images are therefore not formed on the retina. So to solve such problem, we use a convex lens. So now let's talk or describe other types of lenses other than the eye that are used or described in this chapter. So for example here, we are talking about telescopes. So they are raised, okay, or I mean the astronauts, okay, the astronauts or astronauts in previous case, the light coming far away. So astronauts use the telescopes to describe or to receive light coming from very far away distance, okay, and then make it converge to a single point, okay. So these rays enter the object or objective lenses, convex lenses, which focuses them on a real image at the focal point. So in the telescopes as well, there is a main focal point where all the images are formed before received through the eye. So let's see the path, the light path here. They come straight and seems like are parallel because coming from very far distance. They hit the main lens here. They are reflected into this focal point here in the middle. And then it's reflected again to the eyesight where the image is formed again. All right, we have another system, the camera. It's functioning, it have a similar function, but in this case we are using prisms. Okay, so where all the light come through this, here we are using a mirror here in the middle. There is a mirror that's reflected the first prism, then to the second prism, and then to the eyesight. That's for the camera. We as well talking about the microscopes, but here we are talking about a different function. In this case, we are magnifying the small or micro objects. That's the main function of a microscope, okay, that pose an objective, convex lens, and convex. The microscope is using two convex lenses, however, as used to magnify small objects. So that's the main function for the microscope. The lens of the microscope have relatively small focal point. Obviously, yes, the focal point is the smallest in compared to other devices like the telescope or the camera, of course, okay, just to magnify the small objects that we are studying with the microscope. All right, the binoculars, another system. Also here as well, the light, let's see the path of the light. Okay, so the light coming through this lens hit the first prism, similar to the camera. It's reflected to the second prism and then to the eyesight. That was for the binoculars, having different function. Also to catch, also it have similar function to the telescope. We're trying to catch objects, okay, very far away from the focal point. And that's it for this lesson. We'll meet hopefully in chapter 19.